Let's practice writing the Lewis dot structure for some molecular compounds. Let's start out with an easy one. How about HCl? Okay, there's a molecular compound, but what does the Lewis dot structure look like? First off, we need to figure out how many valence electrons we are dealing with. Chlorine has 7 valence electrons. Hydrogen has 1. We know because there's only 2 atoms we're dealing with, of course they have to be bonded to each other. So we can have hydrogen and chlorine. There must be a bond in between. We know that. That represents 2 electrons. Now we have to satisfy the octet rule. Hydrogen's taken care of. It only needs 2. 1, 2. So we don't have to worry about that anymore. What about the chlorine? Chlorine must have the 8, the octet. 1, 2, 3, 4, 5, 6, 7, 8. So we have all electrons accounted for, and there's the Lewis dot structure for HCl. Let's do one that has more than 2 atoms. It can get a little trickier. Okay, here's one that's a little bit trickier. It looks a little bit scary, but don't worry about it. Let's go ahead and take it one step at a time. First, I want you to figure out how many valence electrons we are dealing with. I'm going to use my red marker to indicate that. Each hydrogen has 1 valence electron, and we have 3 hydrogens, so we have a total of 3. Carbon has 4, and maybe I'll indicate little arrows. Carbon here has 4, and nitrogen has 5. How many valence electrons is that? We add them together. 3 plus 4 is 7, plus 4 is 11, plus 5 is 16. Okay, so we have 16 valence electrons to worry about. My next step is I want to figure out the very rough atomic skeleton for this molecule. So looking here, I know that carbon needs to have 4 bonds. So if carbon needs to have 4 bonds, because it needs to have 4 additional electrons, right, to get the octet. So 4 bonds for each carbon. Carbon is usually a central atom. Nitrogen needs 3 bonds, and hydrogen only needs 1. So let's go ahead and try this atomic structure. So we have a carbon bonded to a carbon, bonded to a nitrogen, and then the hydrogens, let's bond them to the outermost carbon. Okay, so I now have the atomic skeleton, but now I need to go in and fill in my electrons to satisfy the octet rule. So I know I have 16 total electrons. Let's figure out how many electrons we've used by simply bonding them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 electrons I've already used, and I need to place 6 more. That's important. And I need to make sure I satisfy the octet rule for all of the atoms. Let's first look at the octet rule. This carbon is just fine because it has 8. 1, 2, 3, 4, 5, 6, 7, 8. So this carbon is taken care of with the octet rule, as well as these hydrogens are stable because they each have 2. And hydrogen is one of those exceptions. It doesn't need 8, it only needs 2. So those are taken care of, but what about this carbon and this nitrogen? I need to place 6 more electrons, and I need to make sure that each of them has 8. Currently, this carbon only has 4. 1, 2, 3, 4. This nitrogen only has 2. 1, 2. Let's go ahead and place the extra 6 electrons. Well, I know that I need to have a total of 8 around carbon, and I know that nitrogen also needs to have 8. Okay, so there's my 6 electrons for a total of 16. Does this work? I don't think so. Let's look at the octet for this carbon and this nitrogen. This carbon is taken care of, right? 1, 2, 3, 4, 5, 6, 7, 8. So we first think, oh, this might work. But then look at this nitrogen. The nitrogen only has 4. 1, 2, 3, 4. So that's not going to work. What about if we created a double bond here? So let's Move those 2 electrons over there. Now this carbon still has 8. This nitrogen now has how many? 1, 2, 3, 4, 5, 6. We still need 2 electrons. What if we move these 2 electrons down into a triple bond? 1, 2, 3. Is my octet rule followed? Let's see. Nitrogen now has 8. 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen is taken care of. That's good. What about carbon? Carbon also has 8. There's my Lewis dot structure. Let's do one more. Here's our next question. What about polyatomic ions? These are covalent bonds because they're nonmetals, but how do we draw the Lewis dot structure for them? We draw them the same way. The one thing that we need to keep in mind is the number of valence electrons. Because there's a -2 charge, that means I have 2 additional electrons in this molecule. So let's go ahead and start by counting up the valence electrons. Carbon has 4. There are 3 oxygen. Each oxygen has 6. So 6 times 3 is 18. Plus, I have 2 additional. 4 plus 18 is 22. Plus 2 additional is 24. I have 24 total electrons that I need to put in my Lewis dot structure. My next task is to draw the atomic skeleton. Carbon has a need for 4 additional electrons, therefore it will form 4 bonds, and it's usually the central atom. So let's start there. Carbon's in the center, and let's attach an oxygen there, and oxygen there. So I have 3 oxygens. How many total electrons have I used so far? 1, 2, 3, 4, 5, 6. I've only used 6 of my 24. I have 18 left. So let's find out what we need to do for the octet rule. Let's first start with the oxygens. 16, 17, 18. Well, perfect. I've used all 18 electrons. So now this structure has a total of 24 electrons. But now is my octet rule satisfied for every single atom? For oxygen, yes. Yes, and yes. But what about my carbon? My carbon only has 6, but it needs 8. In this case, let's go ahead and take those 2 electrons and bring them down to form a double bond. Wonderful. This is my Lewis dot structure. There's a few minor things that we still need to do. First off, we put brackets around polyatomic ions and we indicate the charge. This brings us to another point, and it gives us a new vocabulary word. This double bond can be here or here or here. Which one will it be at? Well, this is called resonance. The actual carbonate ion is a combination of these. It's a resonance hybrid. Let me go ahead and illustrate. The actual molecule of the carbonate ion is called a resonance hybrid. But for simplicity's sake, we can represent it with 3 different pictures. The 3 different pictures would look like this. The double bond could be found on this oxygen, or on this oxygen, or on the 3rd oxygen. Also note that I have brackets with the charge because it is a polyatomic ion. Now in nature, the carbonate ion doesn't exist as this sometimes or as this other times. It actually is an average of these pictures, but for our purposes, we want to use the simplistic Lewis dot structure, and so we can represent the carbonate ion by drawing these 3 pictures together.